Cerebellum, fascinating structure. We'll orient a little bit. So this tiny thing is a medial view. So you've had a mid-sagittal section, and then here's just this section of the brainstem here, and the cerebellum only, taking off the diencephalon and the cerebrum. And this view is not that view, so that's weird. This is like a posterior view. So I don't know what's going on with this lateral view over here. You could just ignore that. Okay, the cerebellum, you can see here, it actually has two hemispheres as well, two cerebellar hemispheres, right and left. It does not have like the corpus callosum. It actually has that structure in the middle. Oops. That is called the vermis. The word vermis is for like vermin, and anatomists thought it looked like an earthworm, which they considered to be vermin. And you can see that, like it's got these weird lines, and the vermis there looks like an earthworm with all of its body segments together. So that's where that got its name, your worm-like connection between the right and left hemispheres of the cerebellum. And then here in the mid-sagittal view, let's look at the brainstem first. This is the pons. See how it really sticks out? That to me is a good visual cue. You're like, okay, there's the pons. Now I can orient and I can think about, okay, superior to the pons, this would be the midbrain. There's two of the corpora quadrumina, an inferior and a superior colliculi. And then inferior to the pons would be the medulla, up till the foramen magnum. And you can see this bit of swelling in the front. That's one of the pyramids. Okay, brainstem. Other things I want you to know. Before I get to cerebellum, I'm going to get there. This is a tube. It opens up here, kind of looks like a triangle-shaped structure, and continues down there. CSF would be in there. So we're looking at some ventricle stuff. So the third ventricle, hopefully you remember, is between the two halves of the thalamus, the right and left half of the thalamus. And then from the third ventricle, it would be like right about here. From the third ventricle, the CSF is going to flow through this tube called the cerebral aqueduct, and it's going to come to the fourth ventricle here. Now it can do one of two things. There's little holes leading to the subarachnoid space, or the fluid could flow down this little tube, starting here. That is the central canal of the spinal cord that we'll learn in 16. Okay, so that's a little orientation of the stuff around the actual cerebellum. There's the cerebellum. This would be the right hemisphere. We already got the vermis. I'm check right. Vermis, we got that connects the hemispheres. Looks like an earthworm. And then this thing, the arbor vitae. Arbor. What is Arbor Day? It's referring to trees. And then vita means life. Do we see a tree here? I do. Look at this little pretty tree with all its branches. I think they should have called it white tree because it's white. And it would be a visual, but that's okay. Arbor vitae is still good. At least it has the word tree in it. So this white tree is, what's white matter? Hopefully you're thinking myelinated axons. So these are myelinated axons going in and out of the cerebellum. Some come in and then let's say some come out to the similar routes. So there's, as in all places, information going in and out. Okay, what is that information? Well, the function of the cerebellum, broadly speaking, is to smooth and coordinate motor movements. Motor information, I should say. So, this is what makes you graceful, or not. Okay, I'm going to draw a little schematic that will hopefully help you understand how the cerebellum smooths, coordinates motor movement. Because motor movement starts up here in the cerebrum. There's this little gyrus right there. Hopefully you're thinking precentral gyrus, one of the ones you had to know. That's where motor information is going to originate. Like, I want to move my hand. The precentral gyrus, it contains the primary motor cortex. So that is the primary place of voluntary, I forgot the word motor, my bad. Primary motor cortex. So those are the neurons that initiate voluntary movement. And they're inside the precentral gyrus, which, by the way, frontal lobe, and the frontal lobe. Okay, so they're going to send their message down to muscles to do their thing. What do we want to do? We're dancing. Okay, so motor information from the primary motor cortex goes to your muscles to tell them what to do. There also is a duplicate of that information that's sent to the cerebellum. So you can think of this as, this is what I think of this information as. What do you want to do? You want to dance. So this is information going into the cerebellum about what you want to do. Now, likewise, this is interesting. The muscles, you remember muscles have sensory receptors. Will tell you how stretched out they are. And the joints have sensory receptors as well, so you can, detect unconsciously usually exactly where your joint position is, where your body is in space. So that sensory information, it does go up to the cerebellum, but it also sends off a duplicate into the cerebellum. So this information in blue, let's switch up colors. This is what you are actually doing. So what you want to do is dance, but what you're actually doing, what you are actually doing. There's often a disconnect between these two. What you want to do doesn't actually match up to what you're actually doing. You'd like to be a good dancer, and maybe you're not. So there's a mismatch here. If the mismatch is bad enough, and often it is, the cerebellum will intervene a bit. And the cerebellum, use in red again, is going to send out, call it information down to the muscles. Think of it as a course correction. It monitors what you're doing and says, no, that's not what we want to do. So I'm just going to alter the movement a little bit. So the cerebellum can do that. And that's how it smooths and coordinates, is it compares these two and tries to get you as close as you can to what you want. So it might send some course corrections down to your muscles to get them to do what they're supposed to be doing. So I think the cerebellum is really well illustrated what it does and its function when somebody doesn't have a functioning cerebellum. So in humans, this will happen when you drink alcohol. So alcohol will screw this all up. The cerebellum doesn't work very well. So not surprisingly, people who have, drank a lot of alcohol, they stumble and fall. They don't have good muscle coordination. They slur because motor information is what causes your speech. Not very big muscles, but you have muscles in your, vocal cords and in your lips and your tongue. That's how you shape words. If your motor coordination is terrible, your speech is usually terrible as well. So you're going to be slurring your speech. So that's an example of a non-functioning cerebellum in a human, hopefully permanent. Hopefully temporary loss of function. Maybe you don't want permanent loss of your cerebellum. Some days I feel like I already have. But I'm going to have a video following this, if you haven't looked at it already, of some cats that have a disorder called cerebellar hypoplasia. I believe it's genetic, but I'm not sure. They're not your typical cats. Their motor skills are a little bit different, as you'll see. But they do live long lives. They just need certain things, like they can't have any hard metal dishes because they'll break their teeth. Poor things. Anyway, watch those. They're super fun and cute.